with a math background that supports AI, ML, and deep learning. Pradeep K. Suri, author and researcher, with a math background that supports AI, ML, and deep learning. However, reviewing and reinforcing specific mathematical topics commonly used in these areas is essential to excel in these fields. Here's a list of key math topics you should revise. 1. Linear algebra. Linear algebra is fundamental to AI, ML, and deep learning. Review concepts like matrices, vectors, matrix multiplication, transpose, and inverse. Understand how these concepts are used in tasks like data representation and transformation in ML models. 2. Calculus. Review differential calculus, including derivatives and gradients. Gradients are crucial for optimizing ML models using gradient-based algorithms like gradient descent. 3. Probability and statistics. Probability theory is essential in understanding the principles behind many ML algorithms, especially those related to Bayesian methods and decision-making. Review concepts like probability distributions, conditional probability, and Bayes' theorem. Also, study descriptive statistics and statistical inference. 4. Optimization techniques. Familiarize yourself with optimization algorithms used in training ML models, such as gradient descent, stochastic gradient descent, SGD, and its variants like ADAM and RMSPROP. Understanding these algorithms will help you tune and optimize models effectively. 5. Multivariate calculus. Review concepts like partial derivatives, Jacobian and Hessian matrices, and chain rule for derivatives. These concepts are essential for working with multivariable functions and optimizing complex models. 6. Information theory. Information theory concepts like entropy and cross-entropy are used in probabilistic models and evaluating the performance of ML models. 7. Linear regression. Review the mathematical foundation of linear regression, including least squares estimation and the normal equation. 8. Probability models. Familiarize yourself with probability models, such as Gaussian distributions, which are commonly used in many ML algorithms. 9. Numerical methods. Review numerical methods used in AI/ML, such as numerical integration and root finding. 10. Matrix decompositions. Understand matrix decompositions like singular value decomposition, SVD, and eigenvalue decomposition, which are relevant in various ML applications. 11. Graph theory. Optional, while not always required, understanding graph theory can be beneficial in certain AI and ML applications, such as graph-based algorithms. Revising these mathematical topics strengthen your understanding of the underlying principles in AI, ML, and deep learning. This will enable you to work more confidently with complex algorithms and models, make better informed decisions in model design and hyperparameter tuning, and develop a deeper intuition for the behavior of ML systems. Thank you.